there any questions on the homework? I posted a lot of information. This week all about polar coordinates. I posted a set of exercises in the online homework. It's not intended, it's just over polar coordinates, not the calculus interpretations that we gave. It's not graded, part of your grade, but it is the online homework, so you can get feedback, are you doing them right or wrong? And if you're a little fuzzy on polar coordinates, it's been a while. I encourage you to at least look at some of them. There are a lot of problems there. I don't remember, maybe close to 15. And I could have picked more. I didn't want to discourage you. There were too many. Also, I posted some pictures of solutions to problems that I just kind of picked at random. And you know, some of them are a little bit tricky. They show some of the things that we can do with polar coordinates we can't really do, or we never found a way to do with other expressions. And so you ought to take a look at them. There's the old four-leaf rows problem, very interesting graph, and then I did an area calculation inside it, and I strongly encourage you to take a look at those. What you ought to do is read the problem, and then don't look at the solution, try to solve it yourself. And if you just read through what I did, it's not going to help you that much. But if you try to solve it, maybe you'll get it exactly right. Check your answer. I have the answer on the picture. One of them, I just have a kind of a small board in my office, and one of them, it's like 3 pictures long to get completely through the work that I did there. The first one was graphing it. The second one is finding the integral, I think. And the third one is evaluating the integral, which that doesn't really have anything to do with polar coordinates. That's about what we learned earlier this semester. So please take a look. A lot of them aren't identified on the calendar. I didn't want to make the calendar too cluttered. But if you scroll down, they'll just be in the panels underneath, and they should have a fairly good title so you can see what's going on. And I'll ask one more time, are there any questions? Anything? Yeah, Nathan. You were just waiting for me to give you a second chance.
I was having trouble trying to find the area inside r equals 11 sine theta of the outside r equals 4.
Okay, yeah, this is a super good problem. And they didn't really do anything like it in class. We're limited. And maybe I could do some more kind of like it and post pictures of it. So we want to be inside r equals 11 sine theta. And outside r equals 4. So since you asked, I'll do your problem. I'm not going to work it all the way out, but I'll at least get to an integral. What's the graph of this polar function? It's a circle. Yeah. What the center of that circle is where?
Origin.
At the origin, the radius is
4.
4. Yeah. That's the easy length. (11 sine theta) is also a circle. Okay. If we'd have had a little more time, we'd have worked that. Let's do it right now. How do I know it's a circle? Well, I know what circles look like in Cartesian coordinates. So if I could convert this thing to Cartesian coordinates, then I could take a look and see, does it fit the form of a circle that we know? And if you watched the videos I posted, my colleague Nick Willis, he does a problem kind of like this. That is, R is a little bit awkward. I want to convert this to rectangular. I want to get rid of the R and the theta. I want to replace it with X and Y. And then hopefully I can recognize the curve. And then what we're going to do is generalize it. We're going to say from now on, we don't have to do that anymore because we know. In fact, let me just make this a constant. And then when we're done, we'll see what happens if that constant is 11. All right, so if you watch the video, then Nick ran into this very same problem and he said, look, R is sort of awkward and we don't really know. We haven't focused on what sine theta is. But I can fix both of those problems. I'm kind of looking at those formulas. Sine theta. So these are the relationships. And next week when you take the exam, you have to know those. It's going to be miserable if you don't know those relationships. We can even write another one. We don't use it all that often, but tangent theta is y over x. All right, so I really love r squared. It translates well. I love r cosine or r sine theta, and I can solve, this has neither of those, but I can solve both of them if I just multiply through by r. I could solve for r, and then square it, but it's easier just to look ahead a little bit and say, man, and I know Nick did this. Nick, remember he did a problem like this. I don't remember if he had numbers in front. I'll write numbers. A sine theta plus B cosine theta. And this also was a circle. He works through it. I don't remember what he used for A and B, if he had the same or if he specified them. I think he did. Maybe they were both two. It doesn't matter. It doesn't matter what they are. The graph is a circle. All right, and then I can write r squared as x squared plus y squared. Or I multiplied by r, and I can write r sine theta as ay. I can subtract the ay over. I'm going to leave a little space. And now what we need to do is complete the square. So on y, I've got squares and I've got y. So I'm going to take this number and cut it in half. You remember how to complete the square. And then square that and add it in, plus a squared over 4. So we take this thing. It doesn't really matter the sign because we're going to square it. I've cut it in half. Gets me a over 2. And then we square it. And of course, I have to add it to both sides because I want to say equals. And then I get x squared plus y minus 1/2 a squared equals, let's write it like this, a over 2 squared. Completing the square just makes it so wonderful. Now we look at what we got and we say that is a circle. The center is at, what's the x coordinate of the center? 0. And the y coordinate?
1/2 of a.
1/2 of a. And the radius?
1/2 of a.
Yeah. A could be a negative number. We don't want our radius, so we'll put absolute value signs on it just in case. It doesn't affect whether it's a circle if A is positive or negative. It just affects the location of it. All right, so now come over here. What's the graph of 11 sine theta?
Circle
It's a circle. Where's the center of this circle?
at 11 halves.
Yeah, now what do you mean at 11 halves? We got 4 variables possibly, r, theta, x, and y.
So it's x equals 0 and y equals 11 halves.
11 halves. This is 8 halves. So 11 halves is about up there. And that's a radius. So that's a circle. It looks like a parabola, but it's a circle. I'll write a word here so there's no confusion. And show it starting to begin. All right, so Nathan, they're asking you to find this area. I'm wrong, opposite. They want, let's see, inside the big circle there, outside, so they're asking when to do it in red. Questions? On either side of the y-axis, are those areas equal, you think?
Yes.
Yeah, I think they are. So what we need to do is integrate. I'm going to use symmetry because I love having pi over 2 as a limit. So the area is going to be double. And our formula, remember, has a 1/2 built into it. And integrate from some not obvious angle, the pi over 2. The function on top is 11 sine theta. So we're using knowledge from way back at the beginning of the semester. The area between we just subtract. And the function on the bottom is 4. And then we have the d theta. To solve this problem based on what we did this week, you might, rely on your calculator to convince yourselves that this is a circle. All right, what we need is the angle here. That's where this area starts. Well, that's where they intersect. So at that point, 11, the r's are the same. It's the same distance on the curves from the origin. So the angle, the r values are the same. I can set them equal. Between sine theta is 4/11, which means theta is the angle whose sine is 4/11. Let's call it alpha. And then when it comes time to do the calculation, we'll use the angle that it is. The angle whose sine is 4/11. There is an angle. And there's the integral. Okay. It's going to have a sine squared, which would be a hard thing to anti-differentiate, except we memorized it, right, way back when. Although, it takes some effort. If I ask this question on the test next week, I would just ask you for the integral. I probably wouldn't ask you to evaluate it. If I really want you to integrate sine squared, I'd do it on another problem somewhere. That's not so, there's not so many things we have to do to get there. Okay? So we reduced it sort of to a problem we learned how to solve back in February. Now all we have to do is integrate sine squared. So we did all the polar coordinate stuff. Any questions? So we learned something very important along the way, and that is these functions, r equals a sine theta, r equals a cosine theta. In fact, we can add them together like Nick did in his video, a cosine theta plus b sine theta. These are all circles. And they all pass through the origin. That's a thing they have in common. These guys, the kind we had, the center is on the y-axis. These guys, the center is going to be on the x-axis. And these guys, who knows? It's not on either axis, so long as a and b are not both 0. Neither 0. It'll be somewhere else, but the graph will pass through the origin. All right, good question. I think every one of us benefits from you asking that question. You ready to talk about next week's exam? So I've said this all along and no one has responded to me yet. I've been posting solutions to problems and I ask you if there's a problem you need to see. I love solving math problems. So, you make my day. Like could you do this thing? Like, promise me you've given me your best shot. And don't just give me stuff to do because you want me to do it. Try to solve it. If you're under a problem, let me know and I'll solve it and I'll post a picture of it. Okay? I don't believe anyone has asked for that yet. And, you know, why not? All right. So next week we have our final exam. We'll tell you some things about it. I've been in communication with MathLab. If you've been using MathLab, they should be open all week. Our exam is Wednesday. It's right here in this room. I've offered you the option, take it on Thursday, 3 o'clock, which is in EHS 325. I need you to let me know if you're going to do that. If for no other reason, because of COVID protocols. So at the end of class today, I'm going to ask you which way you're leaning. Okay, and it doesn't lock you in, but it just gives me an idea. All right. Final exam. Basically the same format we've been working under. I've listed them all out before, I'll list them again. Strict time limit, although we have a full 2 hours on final. We always show our work. No calculator. So I can ask easier questions. And the fourth thing is a note card. How about if you can bring 2 note cards? Or if you don't want to shuffle 2 cards, you can write space equivalent to 2 note cards on a sheet of notebook paper. I'm not going to be very picky about what you do. So sometimes, and I think this is one of those times, the final exam for Calc 2, I like to make it focus on the whole first year of calculus. And we have this theme that's been going on. We learn about limits, that leads us to derivatives. Another limit leads us to integrals. And so at the end of the first year, you know, I want you to show me that you understand, like the first year of calculus, the big topics. And so, roughly, because I'm not going to add up and do the arithmetic, when I'm making the exam out, I'm thinking of it in thirds. I think the first third is derivatives. And I'm not going to ask you anything about the definition. The limit as h goes to 0, f of x plus u. You remember that because, you know, that was super important for us. But then we learned all of these consequences of that definition. And those are the things I'm going to be interested in. The product rule, the chain rule. What does a derivative mean? You know, rate of change, slope of the tangent. So the good news is we've been calculating derivatives all along. It's the nature of calculus that even when we're integrating, we have to do derivatives, right? We're going to use U substitution and so forth. So what I want you to know is just kind of conceptually what the derivative tells us. And I want you to know how to calculate derivatives. I'm going to write specifically the slope of the tangent. That's connected to the conceptual, what we'll list it explicitly. And, you know, by looking at slope, where the slope is 0, we can talk about Optima, maximum and minimums, maxima and minima. I'm not going to get very exotic. But the basic things that we think about derivatives. I'll give you a chance to show me that you understand them. Second, third, integration. Again, there is, the basics, the concept, what's going on here. And I'm not going to, the definition of a definite integral is the limit of a Riemann sum, right? And I'm probably not going to ask a question at that depth of detail, but you should know kind of what you should know. They come from definite integrals. They come from Riemann sums. And of course, there are two things going on here. The first one is antiderivatives. And the second one is definite integrals, and the connection between them, the fundamental theorem. So over here, I wrote computing derivatives is an important thing. And for antiderivatives, our computations are done here and there. We find the antiderivative here, and then the fundamental theorem, we do the arithmetic given that antiderivative. These are things you've all been tested over. If you had me for Calc 1 and 2, and most of you have, then some of the questions I ask on all of those exams, probably not the very first exam, but after that, they're good things for you to look at. So, along with this, we learned some techniques. And I'm going to say this. I'm not going to ask you a question that requires trig substitution. No case 2 and 3 of partial fraction. It doesn't mean I'm going to ask case 1. It means I may. I reserve the right. Okay. So let me just point out a technique that we learned that I didn't exclude. You ought to be ready to go with it, and that's integration by parts. Okay, didn't make the list. No differential equations on the final exam. Okay, we have some material that doesn't quite fit in the first two categories, that is derivatives and integrals, but it will be part of the first 2/3. I'm going to list it at the end. First, I'm going to tell you what I'm thinking of as the third, and that is the new material. So just working backwards, we have polar coordinates. And jamming it all in here at the end. Hopefully sort it out. Parametric equations. Taylor Maclaurin series. And let me remind you the coefficients of these series. I'll write it for Maclaurin. The coefficients of the power series is the nth derivative evaluated at 0 divided by n factorial. There's this n factorial that shows up. So to find the Taylor series, what I have to do is find a pattern in those derivatives. And what I've shown there by plugging in 0 is a Maclaurin. If I plugged in some other number, then it would be a Taylor. Okay, that's how to construct one, and then there are some important ones. How many of you have seen the picture I posted that asked you to find the value that certain series converge to. How many have seen it? 1, 2? Yeah. So most of you are freshmen. You have a few years to go. I have some super good advice. If your professor, if any professor in the future sort of goes out of his or her way to give you extra things to do, like pay careful attention to it. Like it's something that's super important to that particular faculty member. Important. I think the important ones are all Maclaurin series. I'm not going to write them out. I'm going to let you figure them out, but I'll write the functions, e to the x, sine x, or cosine x. Those are the most important ones. There's another one, but I'm going to get it in another category. All right. I'm not quite done. So I want to take a picture of this. Because you want me to remember the things I excluded. Because you're not going to study them, and it wouldn't really be very nice of me to put them on the. So I am recording it. I couldn't find it in recording. All right, and so this is parts of the first 2/3. It is review material. Doesn't quite fit neatly into the derivative and integral category. And that is, I will give you, I'm planning on it, give you ample opportunity to show me that you understand everything about geometric series. They're simple, they're important. I think on the last exam, there were 30 points you could have earned, 30 out of 100, if only you knew how to deal with geometric series. All right. So you'll see them. Fine. Unless I like go totally brain dead, there will be geometric series on the exam. You can expect to see the ratio test.
Are there any other tests that we should expect to see?
Yeah, I'm thinking. Limit comparison, divergence. No others. I think as part of what I mentioned about derivatives, I wouldn't get very exotic, but a question about optimization. I wrote it on the list, and so an applied optimization, I think, is not beyond a reasonable. It wouldn't be a hard one. It would just give you a chance to show me where things are not complicated. You know, maybe it's dealing with a rectangle, something we don't need any fancy formulas for, triangle, circle, that sort of thing. And to find the applied optimal value. And similarly, let me write this on the board. Applied optimization I'm not gonna say, difficulties in the eye of the beholder, so I'm gonna ask what I think is not a very complicated, if I ask one, it's gonna be not very complicated in the big scheme of things, but I'm just gonna put it on the list. And then also, I want you to, well, I think I've already covered area. I asked you to, like, conceptually, what is a definite integral? That made the list, and that's, we think about areas, right? We use integrals to calculate areas, rectangular areas. And then, of course, we revisited areas in polar coordinates. So that's a big part of this exam. The question you might have is like, what about volumes? And so I'm likely to ask a question where any of the three techniques we learned will work. And so if you come armed with knowledge of, like, rock solid knowledge of one of them, it doesn't matter which one it is, you'll be in good shape. Okay? You're not gonna absolutely have to know the shell method. And probably most of you, that's not the one you're gonna memorize, although some people it is. Also, I think every exam so far, the first one only after the fact, it's had optional problems. I think you can expect that again. So maybe, do 5 of these 7, something like that. I haven't really thought 1 second about actual construction of the exam, so I'm not sure what that'll look like. And it might be like in the categories, like derivatives, do 3 of these 4, and then integrals, do 3 of these 4, that sort of thing. I mean, who knows? But watch for that, and that will help your grade. It's a good thing. The downside of it is that, any effort, time you spend on that extra problem, it's sort of wasted because it's not going to impact your grade. But you ought to, dig into it enough to know, like, these are the ones I know how to do. If that's the one I'm not so sure about, 1 or 2, I mean, it could be 2. So watch for that. It'll be made clear in the instructions. Are there any questions? I need another picture. Not that picture though. Yeah. Can we do a? Sure. So for watching the video, I'm not sure you heard the question. Matthew wants to do a ratio test problem. So here we go. Into the 4th times 2 to the n over n factorial. We know that 4th degree polynomials by themselves can't overcome factorial, and exponential functions by themselves can't overcome factorial, but maybe the product can. Let's find out. So we calculate L, which is the limit as n goes to infinity. We plug in n plus 1, the n plus first term. Then we divide by, or because they're almost always a fraction, we've been going straight where we invert and multiply the nth by the nth term. So I thought of something else I need to make you aware of that will be on, potentially on the final exam. I'll do it after we finish this example. So I have n+1 twos on top, only in on the bottom. So one of them survives, I can pop that 2 through the limit. So we've accounted for the twos. And then I have this n+1 over n, both to the 4th power. I can raise them by properties of exponents, just as the fraction to the 4th power. And what happens with factorials? So this is the product of all of the positive integers up to n, and this is the product of all of them up to n+1. So all of these are included here, and the top one survives. What's that limit? The limit of a product is the product of the limits if they both exist. So the first one, n+1 over n to the 4th, does that have a limit? Yeah, what is it, Emma? 1. Second one, does it have a limit? What is it? 0. They both exist, so the limit of the product exists. 2 times 1 times 0. What does that make?
0.
I know, no calculator. And 0, this is the ratio test. What does 0 mean?
It converges.
Yeah, it's less than 1. It converges. So even multiplying polynomials against exponentials, it still can't overcome factorial. Like, factorial has this drive to infinity, screaming to infinity. Okay, Matthew, does that help? Yeah. So the thing that's, I think it's new material. I don't remember, it was on exam 3. If I'm mistaken, you'll let me know, because then I'll think about it differently. And that is power series. Particular, let me call it special. Power series. We did have the theory of power series on the last exam. Remember, we found the radius and the interval of convergence for a couple of power series, but I don't think we have specific ones. And this is kind of like those Maclaurin series. I listed 3 of them out that you really ought to come, not ready to derive, but just to know e to the x, the sum of x to the n over n factorial. So here are the important ones. The very first one, it all starts here, 1 over 1 minus x. This is just a geometric series. So we start with something we know. And it only converges. The Maclaurin series I showed you converge for all values of x. I didn't write that on the board, but it's true. This one only converges for x's between -1 and 1. And then I can play around with this. I can compose it with -x. Now I compose it on both sides, and it works. Gives me an alternating series over here. By the way, you won't have to use the actual alternating series test on this exam. And I'm not going to write it in signal form. And then remember, we can integrate, and we get a.
We will or we won't have to use alternating series?
Will not. Yeah. I can integrate. And I get x minus 1/2 x squared plus 1/3 x cubed. We can integrate term by term. And the interval, the radius of convergence stays the same. We can potentially gain endpoints, and we do here. Remember, we discovered we get the, if you plug in 1, you get the alternating harmonic series, which we know converges, and evidently it converges to the natural log of 2. I'm just going to say, etc. I mean, we can keep doing things. We can take derivatives. I assigned a really good problem. I didn't assign it. I posted a picture of it. And the problem, it has several steps, and it goes way beyond what I would expect you to do on an exam. But the first few is problem number 10. I think I highlighted it. It's going to be down a ways because it's been a while since we have talked about this topic. But it kind of talks us through. For shall I give an example? I teach probability. I used to. I don't think I will ever teach it again. But probability, there are certain kinds of experiments where we run into infinite series. And one of them we run into is, I don't know, should I tell you? It's a waste of time.
You can toss.
N next to the n. And x, it would be a probability of something happening, like rolling a 7 or snake eyes or something like that. The problem we're solving, we would know the value of x. And it would be between 0 and 1 actually in probabilities. It's the probability of something that will.
What would the sum tell us?
Well, if this is the probability of something happening, it would tell me that actually we run into it, we're trying to find the average. Like if you do the thing over and over again, what's the average result? This would look like this. All right, and so if I take this guy and I take the derivative, on the left-hand side, I get 1 over 1 minus x squared. See that? 1 minus x to the minus 1. The chain rule kicks out a minus 1 to turn it back positive. And I can differentiate term by term. I get a 0, and then I get a 1 plus a 2x plus a 3x squared plus 4x cubed. See how that works? I'm like, now it's almost what I need. Notice I need the coefficient to be the same as the power. And I'm off by 1. Right here, the coefficient is 2, the power is 1. Now it's 3. So what I need is another x to push through. And I can do it. Let's just multiply both sides by x. And now I get x plus 2x squared plus 3x cubed. I can distribute on the right, I can distribute the x. And now it's perfect. So I know this is going to converge to x over 1 minus x squared, provided we had a good x. Can't do anything outside that interval. All right. So that's kind of the et cetera. Take these things we know, and this is just a basic geometric series. It could be automatic. This is also, I can get it, the ratio here is the r is minus x, or I can get it by composing it like I talked about before. But it's also a geometric. This is not a geometric series, but I can get what it converges to from the ones that I know. And again, that problem number 10, the first few parts of it, especially. Anything else? Matthew?
Certain things you're gonna say, just the other.
Say it again.
Like, are you gonna take a big exam that you did the other?
Oh. So if I do that, it will have limitations because you remember there have been a few topics we hit that there were no good. And so I think I can do that. And along with it, I'll post the topics that are not covered that on the homework that are going to be covered potentially on the exam. So again, if you're watching the video, we'll ask about review problems posted. And I'll do my best. We'll have limitations. I'll let you know something about those limitations. Maybe sometime on Monday, I can have that done. So are any of you thinking about taking the exam on Thursday? Pardon me? Most of you have physics. All right, so one day the revises 11 of you on Wednesday at 10:15 in this room. Math lab will be open. I think I said that earlier. I'll be available. Like I said, if you have a question, I'd be more than happy. I'd be thrilled to solve a problem and post a picture of it. It needs to be one you've worked on. It won't do you any good if you haven't tried to solve it. But if you have, then you see the solution and you can figure out where things went wrong. All right, well, this has been another strange semester, but thanks for coming along. Maybe in the fall, we can have normal classes. You all can. This is my last year at Fox, so I'm not going to be around in the fall, but good luck with your programs. All right, see you Wednesday.
Thank you for teaching us.
You're welcome, Will. Thanks for asking questions.